So what are trig ratios anyway? As it turns out, it's just a bunch of known values that are in a table. When you punch in sine of 30 degrees into your calculator, it's really just accessing a table of known values. So let's look at one of those tables and at least understand what's going on. From there, we can understand what trig ratios are and what the inverse of a trig ratio is. Ooh. Let's say that we have the sine of 23 degrees. And we want to know what that ratio is. Well, we already know that sine of 23 degrees is referring to a right triangle with an angle of 23 degrees, and that this is just the ratio of the opposite side to the hypotenuse. As I mentioned before, the size of the triangle doesn't matter, so we can actually calculate this without even knowing additional information about the size of the triangle. So to use the table, we know the degrees are 23. So we're going to come down here to 23 degrees and then go to the sine column, which in this case is the first one. And we know that the ratio of the opposite side to the hypotenuse of any right triangle that has an angle of 23 degrees is going to be 0.3907. So as I mentioned before, not only is this going to allow us to find the trig ratios of a triangle when we know the angle, we can actually go the opposite direction as well. So let's say that we had a situation where we needed this really long driveway, and for whatever reason, we knew that it needed to rise up 3 feet and it needed to be about 20 feet long. And we really wanted to know, is that angle going to make sense for driving up it, right? So if that's the case, I know I'm going to be using the opposite side. I know I'm going to also need to use the adjacent side. And which trig ratio is that? Opposite and adjacent? Oh, well, that's tangent. So we know that the tangent of alpha is just equal to 3/20. Well, unfortunately, our angle is stuck here in the tangent function. Well, fortunately, we've learned about inverses before, and an inverse kind of reverses the input in the output. So we actually know that that alpha is equal to the inverse tangent of 3/20. So remember, we started before by looking at the angle and then then finding out what the ratio of the opposite side to the hypotenuse was, the sine ratio. In this particular case, we know what the ratio is, the tangent ratio. And now we just need to find which angle lines up with that tangent ratio. Pretty cool. So to do that, we're first going to have to convert this fraction here into a decimal, since our table is in decimal form. And 3/20 is equal to 0.15. And then I'm just going to go ahead and look in my tangent column until I find that. And in this case, it's actually pretty easy to find. It is right around 9 degrees. It's a little less. So a little bit less than 9 degrees. And here I'm going to go ahead and admit to my ignorance on civil engineering. I really don't have any idea if that's a reasonable grade for a driveway. I think it's okay. But what I wanted to show is that this relationship between the angles and the ratios can go both directions. If you know the ratio, there's only one angle that'll get it to you. If you know the angle, there's only one ratio that goes with that angle. The last thing that I wanted to mention in this is, if you notice, sine and cosine have specific relationships as far as their values go. And if we take a look at them here, and I hope I don't get anyone sick, you're going to notice that none of those values get bigger than 1. So in other words, we know that the ratio, both sine and cosine, is always somewhere between 0, and 1 degrees. And it is actually inclusive of those. And it's important to know what the values are that you're going to be dealing with any sort of function. And later on, when we look at the graphs, it'll make a lot more sense as to why we end up with these values. Now you should have a pretty good understanding of what a trigonometric function is, where it comes from, and at least the basics of how to use it. Later on, we're going to go ahead and see how we can graph these and use these trigonometric functions to find the location of points. And actually, it will lead into a new type of coordinate system, polar coordinates.